These are problems for the Charles Law section in the gas laws unit. The first question says, a balloon is at 12 degrees Celsius and occupies 2 liters. The temperature increases to 50 degrees Celsius and the pressure stays constant. What is the final volume of the balloon? We'll start by identifying our givens. We have 12 degrees Celsius, 2 liters, and 50 degrees Celsius. And then we're looking for the final volume. I know that degrees Celsius is temperature. Those are the initial conditions, so I write T1. Liters tells me that's volume. That's the initial condition, so I write V1 equals 2 liters. The temperature changes. It increases to 50 degrees Celsius. That's my T2. And I'm looking for the final volume, so V2 is unknown. There's one more thing I have to do before I pick an equation and plug it in. When you have a problem where the givens are in degrees Celsius, those have to be converted to Kelvin. The way you do that is add 273 to the Celsius temperature. So in this case, 12 degrees Celsius plus 273 equals 285 K. You have to do the same thing for T2. Add 273. 50 plus 273 equals 323 Kelvin. Now I can pick an equation. Temperature and volume are both changing, so I'm going to use Charles' law. V1 over T1 equals V2 over T2. So you're going to take these values and plug them in. 285 goes in for T1. 2 will go up for V1. V2 stays V2 because we don't know it. And 323 for T2. So it looks like this. There are several ways to solve this algebraically. Some people even like to rearrange the equation before plugging in the values. There are lots of ways to do this, and it's okay, but what I'm going to do is I'm going to do 2 divided by 285 first. That gives me 0.00702. I like to include at least 3 non-zero digits, or like we have 0, 0, then we hit a non-zero digit, and at least 2 more after that. That way I'm sure I'm including enough information on this side here. I write my equal sign, V2 over 323. I want to get V2 by itself, so I have to multiply both sides by 323. That gives me V2 equals 323 times 0.00702. That equals 2.27 liters, and you can plug that in the answer box. Let's look at one more question. A flexible container holds a gas. And when you see flexible, that means the volume can change. A rigid container, the volume does not change. All right, so initially the gas is at 2.80 liters and 253 K. The container is heated and the volume changes to 4 liters. The pressure remains constant. What is the final temperature of the gas? Let's find our givens. So let's see, we have 253 K and 2.8 liters. Those are both initial conditions. So that's T1 and V1. Kelvin is temperature, liters is volume. There's a change. Now volume is 4 liters. V2 equals 4 liters. What is the final temperature? T2 is unknown. Temperature is already in Kelvin, so we can go ahead and plug this into an equation. Temperature and volume are changing, so I'll use Charles' law. V1 over T1 equals V2 over T2. I'm going to plug these in. V1 over T1 equals V2 over T2. Again, you can cross multiply, you can isolate the variables before plugging it in, but I'm going to simplify by dividing these guys right here. That gives me 0.01107 equals 4 divided by T2. When your unknown is in the denominator, you have to do 2 steps to isolate it. First, you can multiply both sides by T2. That gets it out from under the denominator and gives you T2 times 0.01107 equals 4. Then divide both sides by this number right here to isolate T2. When you calculate that, you get 361. The unit is Kelvin for temperature. And you can plug that answer into your answer box.